Imagine taking a proven $30 million fighter jet and pouring in so much extra tech that it ends up costing 4 times as much. Japan did exactly that. The result was a sleek blue fighter that looks like an F-16 at first glance, until you notice the larger wings and the oversized price tag. In fact, Japan's Mitsubishi F-2 Viper Zero turned out to be the most expensive F-16 ever built, with each jet costing around 11.9 billion yen, over $100 million, more than double the price of a Russian Su-30 fighter, and more than double the cost of a F-16. Why would anyone pay so much for a modified F-16? Today, we're diving into the surprising story behind this aircraft to find out. The Mitsubishi F-2 is a multi-role support fighter, essentially a light fighter bomber, developed for the Japan Air Self-Defense Force, JASDF, in the 1990s. Although it was jointly developed with the United States and shares a lineage with the F-16 Fighting Falcon, the F-2 was Japan's first domestically produced supersonic fighter since the 1970s. It officially entered service in 2000, marking a milestone for Japan's aviation industry. Only 94 F-2s were built in total, a tiny fleet compared to the thousands of F-16s around the world, but each one was packed with cutting-edge technology. This aircraft was purpose-built for Japan's unique defense needs. It has a longer range and larger payload capacity than a standard F-16, and it was among the first operational fighter in the world to be equipped with an AESA radar, active electronically scanned array, giving it advanced detection capabilities. With a top speed of Mach 2 and a combat radius of over 450 nautical miles, 830 plus kilometers, the F-2 was designed to cover Japan's vast maritime territory. It replaced the older supersonic Mitsubishi F-1 and supplemented Japan's fleet of F-4EJ Phantoms and F-15J Eagles, filling a critical role as a modernized fighter that could strike ships at sea while still performing air defense duties. In short, the F-2 matters because it kept Japan's fighter development alive into the 21st century, and it gave the country a high-tech tool to defend its shores. The story of the F-2 begins in the early 1980s. Japan's military planners knew they needed a replacement for the aging Mitsubishi F-1 attack jet, and they were keen on developing indigenous aerospace know-how. In 1985, the Japanese Defense Agency, JDA, formally launched the FSX program, short for Future Support Experimental Aircraft, to study a next-generation support fighter. The wish list was ambitious. The new plane should carry up to 4 anti-ship missiles, plus several air-to-air missiles for self-defense, have state-of-the-art avionics, including a secure Japanese-built data link, and achieve at least a 450 nautical mile combat radius on anti-ship missions. Essentially, Japan wanted a small fighter that could pack a big punch against enemy fleets while patrolling far from its home airfields. Initially, Japan considered designing a brand new aircraft domestically to meet these requirements. After all, Japanese industry had successfully built the F-15J under license in previous years, and defense contractors argued that creating a new fighter indigenously would advance their engineering skills and industrial base. At the same time, the JDA surveyed existing foreign fighters to see if any could be adapted. They looked at the American F-16 Fighting Falcon and FA-18 Hornet, the European Panavia Tornado, and others. The conclusion: no off-the-shelf fighter met all of Japan's needs. For example, none of those jets could haul 4 large anti-ship missiles without significant modifications. Japan seemed poised to pursue an all-new domestic design by 1985, which caused excitement in Japanese media. The prospect of a cutting-edge homegrown fighter made headlines. However, building a fighter from scratch is expensive and time-consuming, and this is where geopolitics intervened. The mid-1980s were the height of the US-Japan trade friction era, with American officials often worried about Japan's burgeoning high-tech industries and a ballooning trade deficit. The United States government was not keen on Japan developing a completely independent fighter that might one day compete with American exports or reduce Japan's reliance on US defense technology. In 1987, under the Reagan administration, US Defense Secretary Caspar Weinberger and others began strongly pressuring Tokyo to make FSX a joint US-Japan project instead of a solo Japanese venture. This pressure came amid broader tensions. For instance, that same year a scandal broke about a Japanese company, Toshiba, illegally selling sensitive machinery to the Soviet Union, which heightened US concerns about tech transfers. Facing the possibility of strained US-Japan relations, the Japanese government reconsidered its plans. By October 1987, a political compromise was reached. Japan agreed to base the FSX design on an American fighter, the F-16C Fighting Falcon, and to develop it jointly with the United States. This decision, announced at Japan's Security Council, essentially meant the FSX would be a modified F-16 rather than an all-new, pure domestic plane. Many in Japan's aviation community were disappointed. They felt the project had been derailed by American interference, forcing Japan to abandon a clean-sheet design. Some Japanese lawmakers and engineers openly criticized the deal as one-sided, pointing out that Japan would share its best new technologies with the US, pay hefty licensing fees for American components, and end up with a jet that was only semi-indigenous. Nonetheless, the agreement was set. The FSX would go forward as a joint program with General Dynamics, the F-16's manufacturer, as the primary US contractor working with Mitsubishi Heavy Industries, MHI, in Japan. Under a Memorandum of Understanding signed in 1988, the development work share was split 60% Japan and 40% US. Japanese industry would lead the design modifications, final assembly, and integration of new systems, while the Americans would provide F-16 technology and expertise. To appease US industry and lawmakers, it was also guaranteed that 40% of the F-2's production, by value, would go to American contractors. In fact, the manufacturing plan was almost symbolic in how it divided work. MHI built the forward fuselage and wings, right wing. Kawasaki built the mid-fuselage and doors. Fuji Heavy Industries built the tail and one wing, left wing leading edges, and General Dynamics/Lockheed Martin built major portions of the other wing and the aft fuselage. In other words, each F-2 would quite literally be half Japanese and half American in construction. Even its wings were split between the two nations' factories. This international partnership also meant an exchange of technology. The General Dynamics Agile Falcon concept, an experimental F-16 variant with a bigger wing that had been studied in the mid-1980s, became a starting point for the new design. Meanwhile, Japan insisted on incorporating its own advanced technologies, like composite materials and an indigenous radar, into the aircraft. The stage was set for a unique fighter, one that started as an American design but would be re-engineered to fulfill Japan's specific requirements. With the political wrangling settled and the F-16 chosen as a base, Japanese engineers got to work making the FSX truly Japanese. This is where our story pivots from diplomacy to engineering. The joint development officially kicked off in the late 1980s, and almost immediately, Japan began introducing innovations that significantly diverged from the original F-16 design. One of the first major changes was in the aircraft's wing, a critical factor given Japan's demand for more range and payload. Engineers enlarged the F-16's wing, increasing its area by about 25%. The new wing was broader in span and root chord, wider where it meets the fuselage, with a slightly adjusted shape, including a forward-swept trailing edge. A bigger wing would generate more lift, which is great for carrying heavy weapons and fuel, but it also adds weight and stress to the airframe. To compensate, Japan pioneered the use of co-cured composite materials for the wing's construction, molding the carbon fiber skin and underlying structure together in one piece using an autoclave process. This was the first time such technology was applied to a production tactical fighter's wings. The payoff was a lighter wing despite its larger size, which helped preserve the F-2's agility and range. In fact, the composite wing not only saved weight, but also had a side benefit of reducing the radar cross-section a bit, since radar-absorbent material was used on leading edges. The wing technology was so advanced that it ended up being a two-way street. As part of the deal, the United States got access to Japan's composite wing expertise and later incorporated some of those manufacturing techniques into its own programs. Next, the design team addressed the airframe size and payload. To meet the range requirement, the F-2's fuselage was stretched slightly to hold more fuel. The nose section was made longer and wider than the F-16's in order to accommodate an advanced radar system. Japan's choice of radar was groundbreaking. The F-2 would mount the J/APG-1A ESA radar, developed by Mitsubishi Electric. This electronically scanned array radar allowed for faster target tracking, higher resolution, and multiple target engagements simultaneously, a huge upgrade over the mechanically scanned radars of earlier fighters. The F-2 and a handful of upgraded US F-15Cs became the first fighters in the world to carry AESA radars operationally, beating even the US F-22 Raptor's radar into service by a couple of years. The enlarged nose of the F-2 gave space for this powerful sensor and its cooling systems. The F-2's tail surfaces were also upsized. The horizontal tailplane grew by about 20% in area to maintain stability with the larger wing and added weight. The overall airframe was reinforced in key spots to handle higher loads. For instance, Japan planned for the F-2 to carry heavy anti-ship missiles on its wings, so the wing pylons and structure had to withstand that weight and the stress of low-level flight. The landing gear might look similar to an F-16's, but it was beefed up for a higher maximum takeoff weight. The F-2's max takeoff weight is around 22,100 kilograms versus about 16,000 kilograms for an early F-16A. Even the canopy was redesigned. Instead of the F-16's single-piece bubble canopy, the F-2 uses a three-piece canopy with a central reinforcing frame. This was done to improve bird strike resistance, since the F-2 might be flying at low altitude over water where birds are a hazard. It's a small detail, but it shows how almost every aspect of the jet was reconsidered for Japan's mission set. One of the most significant differences is in the weapons loadout and hardpoints. A standard F-16 has 3 underwing pylons per wing, plus wingtip missile rails and a centerline station, for a total of 9 weapon stations. The F-2, in contrast, has 4 underwing pylons on each wing, plus tips and centerline, giving it 8 underwing hardpoints and 11 stations in total. This design was directly driven by the requirement to carry 4 large anti-ship missiles. Typically, 2 ASM-1 or ASM-2 missiles can be slung under each wing, whereas an F-16 would normally carry at most 2 Harpoon-size missiles total, 1 per wing. By giving the F-2 more weapon stations and a stronger wing, the designers enabled a single F-2 to haul an impressive anti-ship arsenal. It can still carry self-defense air-to-air missiles on the wingtip rails at the same time, and it retains an internal 20mm cannon for close-range engagements. The avionics and electronics were another area of major customization. While the F-2 borrowed the flight control logic of the F-16's agile fly-by-wire system, Japan wrote a significant portion of the software and flight control laws anew. The cockpit was fitted with large multi-function color displays, built by Yokogawa, and even a pioneering holographic heads-up display, HUD, from Shimadzu Corporation, very advanced for the 1990s. Mitsubishi Electric provided an integrated electronic warfare suite for threat detection and jamming. Essentially, the F-2 was given a custom Japanese electronics package, a mix of domestic and some US components. For example, the communication and IFF systems had contributions from Raytheon and others. But the radar, mission computer, INS, and electronic countermeasures were largely homegrown. The result was that an F-2 pilot had a very modern cockpit by late 90s standards, with all the sensors integrated for maritime and air combat roles. Japan even ensured compatibility with a domestic data link system for secure communications between F-2s and other JASDF assets, which was a national requirement from the start. Finally, the engine of the F-2 remained essentially the same as late-model F-16s. The GE F110-GE-129 afterburning turbofan, producing around 29,000 pounds of thrust with afterburner. Japan decided not to develop a new engine, which would have been enormously costly on top of everything else, so they license-built the F110 in Japan, manufactured by IHI. With roughly a 1-to-1 thrust-to-weight ratio at combat load, the F-2's performance in speed and acceleration is similar to an F-16C. It can reach about Mach 2.0 at altitude. The key differences are really in how far it can go and what it can carry. By the time all these changes were hashed out, more than 95% of the original F-16's engineering drawings had been altered for the F-2. The family resemblance is there. An F-2 still looks like a cousin of the Falcon. But make no mistake, the Mitsubishi F-2 is a distinct machine with its own identity. Japanese developers even gave it a local nickname, Viper Zero. Viper is what American pilots affectionately call the F-16, and 0 harkens back to the legendary A6M0 of World War II and denotes Type 0 in Japanese naming. The moniker signals that this isn't just an F-16, it's a uniquely Japanese take on the platform, blending old and new. It wasn't all smooth sailing during development, though. Pushing the envelope with that composite wing led to some teething problems in testing. During flight trials in the late 1990s, the prototypes experienced issues with wing flutter and minor structural cracks, as well as some avionics bugs. Engineers had to reinforce parts of the wing and tweak the flight control software to eliminate the flutter at high speeds. These fixes caused the schedule to slip a bit. The testing phase was extended and the planned service entry was delayed from 1999 to 2000. Despite these hiccups, by the end of the 1990s, the F-2 had proven itself in flight tests and was cleared for production. Let's recap and compare the F-2 to the F-16 block by block, because the details really drive home how far Japan went in reimagining the Fighting Falcon. Airframe size and weight. The F-2 is slightly larger, about 1.3 feet, 40 centimeters, longer than an F-16, with a wingspan of 11.1 meters versus the F-16's approximately 9.8 meters. Wing area is 34.8 square meters, 375 square feet, roughly 25% greater than the F-16's 28 square meters. This gives the F-2 a higher max takeoff weight, around 22.1 tons, 48,700 pounds. In essence, it's a bulked-up Falcon that can carry more fuel and ordnance. The larger tail and slightly stretched fuselage ensure it remains stable and controllable with those changes. Materials. To manage the increased size without a big weight penalty, Japan made extensive use of graphite epoxy composites in the wings and other structures. The F-16's wing is all metal. The F-2's wing is primarily composite, making it lighter and somewhat reducing its radar signature. This was cutting edge in the 90s, a precursor to later fighters, like the F-35, which now also use a lot of composite materials. Radar and avionics. The F-2's J/APG-1 radar was the world's first fighter-mounted AESA radar. For comparison, F-16s of that era had the AN/APG-68 mechanically scanned radar, and the US wouldn't field AESA on its frontline fighters until the 2000s. The J/APG-1 gave the F-2 excellent detection range and the ability to track multiple targets, ideal for spotting low-flying cruise missiles or small ships against the clutter of the sea. Coupled with that, the F-2 introduced a new digital flight control and cockpit system with 3 large LCD multifunction displays and an advanced HUD. By contrast, 1990s F-16s had smaller monochrome displays and older analog instruments. The F-2 also integrated an indigenous electronic warfare suite and digital data link, tailored to Japan's needs. Hardpoints and payload. The F-2 can carry roughly 8,000 kilograms of weapons/fuel externally, including up to 4 ASM-1 or ASM-2 anti-ship missiles, usually 2 under each wing. A contemporary F-16C might carry 2 Harpoon anti-ship missiles and 2 wing tanks at most in a similar configuration. The F-2's extra pylons also allow more flexibility. It can carry missiles, drop tanks, or jamming pods in various combinations. Notably, Japan often equips the F-2 with both anti-ship missiles and a pair of medium or short-range air-to-air missiles during training exercises, essentially letting it act as a multi-role platform that can defend itself while striking naval targets. The internal weapon is the same M61-derived 20mm cannon, JM61A1, for strafing or close combat. Engine and performance. Both F-2 and late F-16s used the General Electric F110 engine, approximately 29,000 pounds force thrust. In terms of raw speed and acceleration, the differences are minor. The F-2 is plenty fast, Mach 2 class, but its larger wing gives it a slightly lower wing loading at the expense of a bit more drag. That translates to better maneuverability at slower speeds and heavy loads, good for dogfighting or carrying big missiles. But an unladen F-16 might retain a slight edge in top speed or climb just due to being smaller and lighter. In operational use, both are nimble fourth-generation fighters, but the F-2 was optimized to carry heavy loads without sacrificing handling. In summary, the F-2 is to the F-16 what a tuned, customized car is to a stock model. It's the same basic vehicle, but so many parts have been swapped out or upgraded that its capabilities and character are unique. Japan took the F-16's core DNA, its agility, reliability, and cost-effective size, and grafted on enhancements for range, payload, and technology. The result was a hybrid, part Falcon, part cutting-edge experiment. And like any good experiment, it wasn't cheap. It's worth noting that all these modifications drove the cost way up, which is why the F-2 ended up infamous for its price. The R&D program cost roughly 327 billion yen, about $3 billion, double what was originally estimated. Because only about 90-odd aircraft were produced, the development cost per plane was very high. When you amortize it, each F-2 effectively cost nearly 4 times as much as a standard F-16 off the production line. Even factoring out development, the flyaway cost of one F-2 was around 12 billion yen, greater than $100 million, in early 2000s yen. For comparison, at that time a brand new FA-18E Super Hornet, a larger carrier-capable fighter, cost maybe $55 to $60 million, and a Russian Su-30 was even cheaper to buy. So the F-2 was in a league of its own price-wise. Japan was essentially paying a premium to fuse its domestic tech with a proven airframe in limited numbers. This cost controversy became a political hot potato domestically, with media dubbing the F-2 Golden Eagle or other nicknames implying it was overly expensive.